Good morning. Today we are going to study our topic on the introduction to SR flip-flop. As you can see in the diagram, we are having this is the circuit diagram of the SR flip-flop, and you can see that we are making use of the NAND gates in this circuit diagram. This is the logic symbol of the SR flip-flop. In this logic symbol, you can see that the clock being connected is there is a edge triggered clock being connected. This is the truth table of the SR latch, and that too particularly of the NAND gate. And I would like to draw attention of you all that earlier in our earlier video lectures we had discussed on the introduction to latches, and there we had proven this truth table, that how we are getting these values. So I request you all to go through that, because in our further this introduction to SR flip flop we are going to make use of this truth table. Fine. Now coming back to our this circuit diagram, you can see in this we are having, this is the main, the NAND latch, and we have connected the additional circuit, and here we are having this S and R inputs. There is a clock connected, and these are the NAND gates. This is NAND gate, this is NAND gate, and these two are NAND gates. So this input now is I have written as S star, and this one is R star. Now here from the circuit diagram you can note that the S star output is nothing but it is S into clock and complement of that. That is, I have written over here, S star is what? S into clock and complement of that. Similarly, R star is R into clock and complement of that. So I have written R star here, R into clock and complement of that. So this is nothing but, as we apply De Morgan's theorem to these two, we get S bar plus this clock bar for S star, and for R star we get as R complement plus clock complement. Fine. Now to understand the working of this SR flip flop, let us start with, initially we have clock is equal to 0. It means in the very first step, the step 1, what we are doing is there is no clock being applied to this particular circuit. Being applied, that is this is 0 and this is 0. In that case this will be 1 and this will be 1. When these both are 1, so finally what will happen? Ultimately S star will be 1, R star will be 1. So coming here, S star is 1, R star is 1. And now let us have a look at the truth table of this SR latch NAND gate, in which when these both are 1 1, this is the last combination of inputs over here. You can see that the output is, it is a memory state. So this is what we have written over here. It is a memory state, that is, there is a no change in the outputs which is stored in the last stage. Also, one thing more to notice over here is that when there is no clock being applied, in that case the inputs of S and R doesn't matter. So here we have put a cross at the input of S also, at the input of R also. These are The meaning of this is that it is a don't care condition, and also this is what the logic of our this connecting the clock as an input is, since without this we had seen in our earlier lectures that the inputs of S and R can be changed intentionally or accidentally. So the latch or the flip flop makes no sense in that case. That is why for the latch or flip flop to be effective, we must have some controlled input being given. So this is why we have attached the clock as an input. So the operation of this flip flop depends on the working of clock now. Now let us take our second case in which now we have made clock as 1. This is our second case in which there is a clock, it is 1 now, and let us imagine S and R inputs to be 0 0, this one. Now as you can see, this is 1, so this will become 0 as there is a complement of this, and when we have taken S is equal to 0, so this complement will make it as 1. Similarly here we are getting the complement of R, that is complement 0 is 1, so S star and R star, these both will be 1 1 in this case. So having a look at this table, you can see that in this combination of 1 1 we are getting the same memory state again. So that is what we have written over here. When we applied the clock and when S is 0, R is 0, it is a memory state. That is, there is no change in the outputs. Now let us take another step in which now we are making S is equal to 0 and R is equal to 1. So now coming back to this, apply the clock. Now S, we have made S is equal to 0 and R is equal to 1. So this will become 1 and this will become 0. So we are getting S star as 1 and R star as 0, and then having a look at the truth table, so S star is 1, R star is 0, we are getting Q output as 0 and Q bar as 1. So this is what we have written over here, Q output as 0, Q bar as 1. Now let us take this step in which having the same clock being applied, now make S is equal to 1 and R is equal to 0. S is equal to 1 and R is equal to 0. We are going to get S is equal to 1, R is equal to 0. So we'll get S star as 0 and R star as 1. So 0 1 we are going to get Q as 1, Q bar as 0. So this is what we are getting, Q as 1 and Q bar as 0. Now let us consider the final combination, that is the final step in which we have applied both the inputs S and R to be 1 and 1 both. Now here having the clock being applied, this will become 0. Now this is 1, this is 1. So in this case both S star as well as R star, these both will be 0. And now having a look at the table, we are getting from the very first entry that this is the not used state, that is, it is the invalid state. So this is all about the working of this particular SR flip-flop is, and once again I would like to draw your attention to the importance of this particular truth table of this SR latch NAND gate, which I request all of you to learn this properly, and also the truth table of this SR flip flop, as in our coming lectures, video lectures, we will be discussing this quite oftenly. Thank you.